Hey everyone! Today we are diving into one of the absolutely coolest, most powerful ideas in all of programming. We're talking about how we can teach our code to be smart, to actually make its own decisions. But to get started, we're not going to look at any code at all. Nope. Instead, you and I are going to play a really quick game.
Okay, so the game is super simple. I'm just going to give you a few instructions, and all you have to do is follow along in your head. That's it. Ready? Let's do this.
All right, first up, think about your last name for a second. Go ahead, count the letters. Does it have more than 5? If the answer is yes, I want you to picture a big square in your mind. If not, no big deal, just imagine a circle instead. Okay, next one. Quick, look down. Are you wearing anything green? A shirt, socks, anything? If you are, do a little bit of math. What's 3 plus 2? If you're not wearing green, you don't have to do a thing. Just hang tight. And for the last one, listen really closely. If you can hear me tapping my pencil, I want you to imagine drawing a big X. See? This one's a little different, right? It depends entirely on what's happening in this exact moment.
So let's think about that. What was so different about those instructions compared to me just saying, hey, draw a square? Well, in every single case, you had to check something first, didn't you? You had to ask yourself a little question before you knew what action to take.
And that little if part of the question, well, that's the key to this whole thing. And in the world of programming, it has a special name. That if part, the question you had to answer, like, is my name longer than 5 letters? That's called a condition. A condition is just something a program checks to see if it's true before it decides to do something. You can think of it like a fork in the road, where the program has to stop and look at a sign before it chooses which path to go down. And the instructions themselves, the ones that use these conditions, are called, you probably guessed it, conditionals. These are special statements in our code that only run if their condition is met. This is the secret sauce that makes our programs feel alive and interactive. But here's the catch. Computers, for all their power, are actually pretty simple. They can't understand a complicated question like, am I wearing something green? They need every single question boiled down to one of only 2 possible answers. And this brings us to a super important term, a Boolean expression. Now, it sounds fancy, I know, but all it means is a question that can only be answered with either true or false. For a computer, there's no maybe, there's no kinda. Everything in its world is black and white. Yes or no, true or false. Let's see how this actually works. On the left side, we've got expressions that are true. Is 3 greater than 1? Yep, that's true. Is a character's x position less than 400? In this case, true. Now look at the right. Is 4 equal to 7? Nope, that's false. Is the school name equal to Hogwarts? Also false. See? Every single time, the computer just boils it down to a simple true or false. So, to build these true or false questions, programmers use a specific set of tools. We call them comparison operators. Think of them like the symbols you see here. They're what we use to compare 2 things, like checking if a score is greater than a high score, or if a password is exactly equal to what's stored in a database, using that double equal sign. This is literally the grammar a computer uses to think. Okay, so we've got our conditions, and we know they have to be either true or false. So now let's put it all together and look at the most basic, the most fundamental conditional statement in all of programming, the if statement. This is what it looks like right in the code. It's pretty simple, actually. You have the word if, then you have your condition, your true or false question, inside the parentheses. If that condition turns out to be true, and only if it's true, the computer runs whatever code you put inside those curly brackets. So the computer's thought process here is incredibly logical. First, it checks the condition. Then, it asks itself one single question. Is this true? If the answer is yes, it acts. It runs the code. If the answer is no, it just skips that chunk of code completely and moves on to the next thing. That's it. It's that simple and that powerful. And here's a perfect example. Imagine you're making a racing game. You could have an if statement that is constantly checking, hundreds of times a second, if the race car's position is past the finish line's position. For most of the race, that's false, right? So nothing happens. But the instant the car crosses the line, that condition becomes true. And boom, the code inside the brackets runs, and you win flashes on the screen. Now, this isn't just for making simple little games. This one idea, this if-then logic, is the secret engine powering almost every single app and program you use every day. Let's talk about why this matters so much. I mean it. You see conditionals literally everywhere once you start looking. Think about logging into an app. The code is asking, if the username and password you entered are correct, then log the user in. Or in a game, if the player touches a coin, then increase the score. That logic, that decision-making, is the invisible engine behind almost our entire digital world.
So, it all boils down to this. Conditionals are what make programs flexible. They're what allow a single piece of software to react and behave in a million different ways depending on what you, the user, are doing or what's happening in the game. It makes them dynamic instead of static.
So I'll leave you with this little challenge. Now that you've peeked behind the curtain, now that you understand this core logic of if this happens, then do that, start looking for it. The next time you play a game or use your favorite app, ask yourself, where are the invisible decisions being made? Where are the conditionals? You're going to be amazed at how often you find them.